Okay, 6 inch, your subgate thickness is 6 inch. But you can also test out with 8 inch, 10 inch, 12 inch, 14 inch, and up to 18 inch. So the figure or the graph itself, actually the limits is for the subgate thickness, subbase thickness, sorry, is up to 18 or even 20. 20 inch is the thickest. Okay. Why 20 inch is the thickest? Because economically, if you design anything more than 20 inch, okay, that will be very, very expensive. Right? So the recommended thickness, okay, the lowest recommended thickness is about 6 inch. Okay, anything below that, you may have the future you may have issues in terms of your the design is not as according to the standard ataupun the design cannot sustain the traffic load, the potential traffic load they will apply on the road. So in AASHTO, it's already giving you some what is it, guideline where your maximum design may be up to 20 inch, for example, when it comes to your sub base, and the lowest is that is on the 6. Right? Anything below 6 may not be feasible, may not be workable for your road base. Okay? So all these are based on assumption. Okay? A lot of these are based on assumption. AASHTO old design is not like the flexible pavement that I have shown to you, which I have discussed with you before I took my leave. Kalau JKR punya design, right? JKR punya design based on catalog because they have done away with all this. They have do a lot of the calculation. They have collected many evidence, and then finally they compile it into a catalog base. Okay, of course, if I teach you guys, okay, if I teach you guys back before 2010, 2012, okay, all my students have to do manual calculation. All my students have to do assumption for their flexible pavement. But in your case is that you just have to look at what are the data that is given to you and you plug that data in and then you identify which particular catalog that you are going to use. And that catalog will give you the thickness already, okay, the standard thickness. Right? All these standard thickness are based on JKR past research as well as the evidence from the past design they have done. Okay? So you don't have to crack your heads to do a lot of assumption. But in AASHTO, if you look at all this, it is still based on assumption. So you need to start with all your assumption, first assumption, second assumption, third assumption, until you get the optimum value, until you obtain the right thickness that is not too expensive and yet sufficient to achieve the minimum strength for that particular road. So this is what you have to understand. So yang ni kebanyakannya dia adalah projected ataupun doing assumption. Okay, dia tidak straightforward. Okay. But of course nowadays with the advent of technology, everything can be calculated based on software. Right? But in the past, we still have to use our engineering judgment to do assumption. So that is something that you have to take note of lah. Right? Okay. So for the next one, any other questions for that? Before I go to the next example lah. Any other questions? Okay, no question, right? So let's move into this. See, okay, right. Let me go to the example for designing a rigid pavement based on the equation method. Okay, let's move on to the equation method. Okay. You can go through the video again later on. Okay, so for this example, it is taken from again Nicholas J. Garber and Lester A. Hoyle. Okay, the example is 20.3 and 20.4 in page 1107, designing a rigid pavement using the AASHTO method. Okay, let's look at the questions. Okay, so this example is for the designing of a rigid pavement using AASHTO method. So the use of the chart is demonstrated with the example given in figure 2013. In this case, input values for the segment 1 of the chart, figure 20.13, are effective modulus, subgrade reaction is 72 pound per inch cube, mean concrete modulus of rupture SC is 650 pound per inch square, load transfer coefficient J is 3.2, drainage coefficient CD is 1.0. So these values are used to determine a value on the match line as shown in figure 2013. Okay. Input parameters for segment 2 of the charts are match line value determined in segment 1, design serviceability, reliability, overall standard deviation, cumulative 18 kips SR. Okay. So cumulative 18 kip SR, this is the standard lah. Even in Malaysia also we use 18 kip. 18 kip SR is also equivalent to 5 times 10 power of 6. Okay. So the required thickness of the concrete slab is then as shown in figure as in 10 inch. Okay. So what happened is that if you look at this chart, okay, you take in all the example. So the first example is that the effective modulus of subgrade reaction is taken as 72. So you look for the number of number 72 here. So this is 50, this is 100, so 72 is somewhere here, somewhere at point A. So what happens is that you draw a straight line up towards the concrete elastic modulus E. Okay? Your concrete elastic modulus E, which is to the 10 power of 6, is 5. So you look for the number 5 in the graph here. Okay? The chart here, there's graph 3, 4, 5. So number 5 is over here. So you put the line, you draw the line straight, touching the 5. Okay, 5 times 10 power of 6 pound per inch. And what happens is that you draw a straight line towards the C. Okay, towards C. And you try to see from C, you look at what is the given value of mean concrete modulus of rupture, SC. Okay, so here it is already given as 650. So you find the value 650. Okay, so somewhere here lah, 650. What happens is that you draw a straight line straight away touching the transiting line. Okay, this is TL is transiting line. You draw straight to D. Okay, draw straight line to D. So from here, you look at what is the load transfer coefficient J. So load transfer coefficient J is given as 3.2. So again, you look for 3.2. 3.2 is somewhere here. Then from the point D here, the transiting line, you draw a straight line straight towards the next transiting line, which is at point E here. So once you have completed this line, okay, so from the point E here, you look at what is your drainage coefficient. So your drainage coefficient is CD is 1. So the value of 1 is over here. So what happens is from the transiting line E, you draw straight towards your coefficient and check straight away, go to F. Okay. So what is your merge line? Okay. Merge line. Okay. So this is your match line. Right. So what happened is, because this chart is a very long chart, you have a segment number 1 and segment number 2. So you end your segment 1 at point F, where the match line stops at about 75. 75 or 74 lah. And then from the match line, you go to the next chart, segment 2. So your match line just now is at 75. Yeah, 75 or 74. And you look at what is your design serviceability. Okay, it's given as, if you look at the design serviceability earlier on, is the initial delta PSI, dekat bawah ni, delta PSI is the initial, or the first part is 4.2, and then the terminal index, present performance serviceability index, is 2.5. So 4.2 minus 2.5 equals to 1.7. So what happened is that you look at 1.7, somewhere near the 2. So you draw draw a straight line towards this chart. Okay, from this chart onward, then before you draw into this line, you have to go downward. Okay, start from the reliability here. So your reliability is given as 95% reliability. So your overall standard deviation is 0.3. So what happens is that from 95%, you draw a straight line towards the transiting line here. Okay, once you draw this transiting line across 0.2 something, 0.2 something. So you touch here the line, then what you need to do is you go look at what is your estimated total 18 kips. Okay, 18 kips just now is about 5, isn't it? 5 times 10 power of 6, okay, which is in millions. So what you do is you draw a line straight away, crossing the 5, touching the graph here, okay, the table here. So from here, you draw a straight line across. Just draw one straight line upward. Just lukis saja macam tu. Terus. And then from here, you go draw a line cross, horizontal line across. Just buat macam tu. So the point yang mana dia transit tu, okay, yang dia cross each other, that is your thickness. That is your estimated thickness. That is your proposed thickness for your rigid pavement. Boleh faham? Any question? Everyone okay with this? Yeah. So again, I just want to remind you again, from this segment 2, okay, first you start with the match line. From segment 1, you start the match line and draw across the design serviceability loss, okay, your delta PSI. So you draw across, you stop your point here, okay. The next step in this segment 2 is after you start from the match line, you start from the reliability first. Okay, you start from reliability. Second, you start from reliability. Then you draw across to the transiting line, and then check what is the given 18 kips. Okay, equivalent single axle load. Okay, which is given as 5 times 10 power of 6. So you draw across, and then you stop at this point. So from this point onward, you draw a straight line up. Okay, straight line vertically up, and then from this point, okay, from the design serviceability loss just now, the point that you stop there, you draw a horizontal line across. So where the line cross, okay, that is where the answer is. That is where your estimated thickness design. Okay. So look at your questions, okay, check your question, check your data, then only you plot. You cannot simply just draw it and then you just assume that that is your thickness design. So you must have all the information provided, given when you use this nomograph. Okay, so when you use this nomograph, it's slightly easier lah, okay. And what happened is that, okay, after you have done or after you have used your nomograph, you can check with your equation. Okay, you can check with the equation. So this is the equation. You can still find, after you input everything, okay, after you have inputted everything in this equation, you find that your proposed thickness is very close to the nomograph, which is about, if you're using equation, it's about 9.9, which is very close to 10 inch as well. Okay, so the nomograph and the equation, okay, if your nomograph calculation estimate here is different, very much different than your equation, then that means that there's something wrong either with the way you plot your nomograph or you insert your value in your equation. So technically, both the nomograph and the equation should not have too much difference. Okay, so I use either way. Okay, you can double check. Okay. For your PBL also, you should check with your nomograph. You should use your nomograph as well as the equation. in order for you to check whether your nomograph, you plot your nomograph correctly, ataupun your equation, maybe some of the values that you insert in your equation is incorrect. Okay, so this is how you do the checking, and this is how you determine based on assumption what is your thickness for your rigid pavement. Right. Any questions for this? This is required in your PBL. Your PBL design, you need to do some assumption as well. Okay? Your assumption. And there are also some values that is slightly different. If you look at your PBL2, I don't know how many of you have read the brief for the PBL2. Okay, each team members will have a different design, will have a different thickness. Okay, you will propose a different thickness based on the requirement. Berapa orang yang dah baca brief PBL luar? Belum. Mengaku je lah belum. Belum. Anyone? If you have read, you put a number one there. You type in the chat, you put number one. At least I know how many of you already go through the PBL2. Kalau tak, tak dah lah. Kalau tak, kosong lah. Letak je lah kosong. Kalau tak baca lagi. You won't get penalized for that anymore. Anyone? Nobody want to answer. Too busy with PBL1. By the way, can you hear me? Okay, only one person is listening and is putting the number. Yang lain tak tahu pergi mana sudah. Semua dah tidur lah. Tak apa. Kalau dah tak kosong pun tak apa. No, you guys are still busy. Busy with PBL1. Alright. Okay. It's okay. Alright. Kalau line slow pun tak apa. I know my line also is a bit slow. No worries. Okay. Right. So I assume many has yet to read the brief lah. Okay, no worries. We still have time. Settle up your PBL1 first, and then PBL2 should be not that difficult lah. Not that difficult lah. Cuma kena pandai-pandai atur masa sikit lah. Okay. Right. Okay. I think that's about it for the design lah. Okay. Unless you guys have any questions so far, I will share with you the recording for today's class, right, for you to have a more understanding on the design part. Okay, I will share the recording later, and if you have anything, we still have time. Okay, hari Jumaat pun kita boleh bincang lagi kalau rasa masih lagi confused. But I just want to remind, please, I will open up the e-lead. Please remind your friend yang tak ada dalam kelas, tak ada dalam online, right, to actually to try to answer, because there's a lot of you yang belum answer lagi. I give you until the end of the week lah, end of the week until Sunday untuk finish up the answer. Is that alright? Okay. So please remind your friend lah, yang lain lah. Right? As yeah, stop recording already. Okay. As of ni, I somehow found out that there are unfortunate incidents happen two weeks ago lah, right? With your batch, right? So I'm not sure siapa, tapi I hope you're here, and I hope you will be sembuh lah secepat mungkin lah, right? So just heard the incident, I think last week kot. So it's a very unfortunate incident lah. So I hope that nothing major, nothing serious happen lah. So hopefully you guys also at least ask around lah. Kalau tak perasan pun cuba-cuba tanyalah siapa yang ni, bagilah semangat sikit dengan kawan. Okay. Right. Okay. Saya bagi 1 minit. Anyone want to ask questions? Okay, while I put up the QR. Okay, Civil berapa? Civil 1, Civil 2, Civil 3? Okay, aku one by one first lah. Okay, any question so far? Kalau ada yang tanya, boleh lah tanya. Siapa yang tak scan lagi? Civil 1 ke Civil 2 ke Civil 3 yang tak scan ni lagi? Belum scan lagi. Okay, siapa yang belum scan, you can scan, you put in the chat which Civil 1, 2, 3 yang perlu saya buka. Dan yang lain pula, terima kasih kerana sudi hadir pada hari kedua tahun 2024. I wish you guys all the best and in the coming days for the whole 2024. Be very, very challenging for all of us. Right? And thank you for coming on the second day. Right? And wish you guys all the best lah. So that's all for me today. Okay. Hope to see you guys on Friday lah, our next class. Okay. Siapa yang dah scan, bolehlah tata. Yang belum scan tu bolehlah bagi tahu saya yang mana satu. Okay. Or you want to ask questions, can still spare some time for you if you have any questions to ask. Ya tanya apa saja PBL1 pun boleh. Tapi depend dengan apa soalan dia lah. Civil, sekarang Civil 2 ada lagi, Civil 3 ada lagi yang missing. 13 orang je. For those yang sudah, bolehlah log out lah. Okay. So that's all for today. I will upload the recording as soon as the Webex process lah. Happy New Year to everyone. Okay. Jumpa
Thank
lagi
you,
hari
sir.
Jumaat. Thank you.
Thank you, sir.
Alright.
Sir,
Jumpa lagi.
bye.
Alright. Jumpa lagi. Ada lagi yang